All right, welcome to Color Theory 101, back to first grade, kindergarten. We'll know a little bit about this stuff, and then we're going to talk about how light operates in relationship to color. So I'll start on the board here. I've listed the elements of color, and the elements of color, of course, include the hue, which is the redness, blueness, or yellowness of color, and we call that a hue, and every other color in between. The value is the difference between dark and light of a color, and we can see different values of color in the same scenes that we may be photographing, depending upon how sun is hitting them and shadows. We also see intensity in color, and a lot of this color is related to the painting styles that we learned in first grade. But this is the purity, or in a sense, the intensity, what we will use as a way to intensify our photos when we get into Photoshop is we call it the saturation of color. So we can saturate that color. And then we talk about the temperature of color, colors being warm and or cool. So here we see I have a little color wheel, red, violet, blue, green, yellow, orange. And when we look at the structure of color, the primary colors, of course, we know them as red, yellow, and blue. Now, this is going to be a little bit different when we get into how we deal with light. These are the primary colors that we mix in pigments and paint. The secondary colors, of course, are orange, violet, and green. What that means when we mix paint, we start with the primary colors red, yellow, and blue, and when we mix red and blue together, we can get a violet. When we mix blue and yellow together, we get a green. When we mix yellow and red together, we get an orange. And then, of course, there are a variety of tertiary colors, and that is by mixing the primaries in different relationships. A little bit more red, a little less yellow, a little bit more blue. Of course, our eyes see things a little bit differently, and the camera sees things a little bit differently when we get to the color of light. And so I want to talk a little bit before I move on to that. Three very important things that we need to know about color, and how we use color can really express or be used very expressively to illustrate a point in our images. We can look at monochromatic style of color structure, and monochromatic style could be a sepia tone photo or a black and white or what we call grayscale photo. If we use complementary colors in our photos, if we're dealing with textures or close-ups or beautiful colored clothing, complementary colors we will find opposite on the color wheel, like blue and orange. Those are complementary colors. When we put those colors together, surfaces of images, whether it be a print or a screen, tend to feel like they vibrate. Green and red are complementary colors, as well as yellow and violet. And complementary colors could add a little bit of touch extra to our compositions, to our concepts that we're putting together in our photographs. The other thing is analogous colors are harmonious colors, and those colors are on the color wheel adjacent to each other. So red and orange are analogous or harmonious colors, as well as green and blue. And this sets up temperature of color being either warm or cool when we use these analogous colors. And certainly the use of complementary, monochromatic, and analogous color schemes can enhance the quality of our photos. And that's kind of why I really wanted to get you a sensibility. What type of hue are we using? What are the values that we see in those hues? What are the intensities, purities, and saturation of color, the color temperature, the structures of color, particularly monochromatic, complementary, and analogous colors? Using these ideas in building composition helps strengthen the quality of our photos. Now, of course, light does not work this way. Light, in our eyes, our cones have cones that read a variety of different colors. Guess what those colors are? They are the same color that we hear, RGB color, red, green, blue color. This is the way the cone sees in our eyes sees color through those red, green, and blue images. Additive primaries of light. When we take colored light and we blend colored light, blue light, green light, and red light together in equal amounts, we will get pure white light. And this is the white balancing process that we go through in our camera. Color balancing, color correction is coming up with that pure white light. Now our CCD captures the image in red, green, blue layers and creates an RGB image by bringing those layers together. Now, of course, the color of reflected light is what we see. So when light is shining on an object and reflects off of it, the color that is reflected is the color that we actually see. When we blend these colors together in light, we can blend together different temperatures of light. Every color that we can see can be blended in varying degrees of additives of green, blue, or red light. Of course, color temperature is based on kelvins, and sunlight is rated at about 5,500 kelvins, and incandescent lights that we find inside rated 3,200 to the fluorescent tubes that we see about 4,000 Kelvin. This is why when we take a picture inside with our little point and shoot camera and we're under fluorescent incandescent bulbs, our coloration in our photo appears to be a very yellow color. Now, there used to be film that we would use to adjust for that. Today we do white balancing. We'll talk about that later. Of course, the chromatic colors that we know when white light is shot through a prism, Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet, will emerge from the other side. These are called the chromatic colors. When all the colors are reflected off of a surface like this board, we see white. When all the colors are absorbed by that surface, we see black. So the blending of red, green, and blue additive lights can, in equal amounts, create a perfectly white light, or we can have varying degrees of every shade of color imaginable. Now, this is the way the eye sees, and of course, the camera records 3 separate coloration images, and that is translated and interpolated to create an RGB image in which we work from in Photoshop and print off in our inkjet printer. So, a little bit about color theory. We'll see you